All right. Hi, everyone, and glad to see so many of you here. My name is Pyry Takala. I'm the CEO of True AI, and I'd like to tell you briefly today about a little bit about our company and hopefully a little bit more about how to build self-learning conversation systems. And as mentioned, if you have a burning question, feel free to interrupt. Otherwise, let's have a chat also at the end. So what do we do at True AI? Let's start with that. We are a bunch of deep learning researchers. I'm sure most of you at least know what deep learning is these days. And we're building machines that can converse. And we're starting this in the domain of customer service. In the future, we are of course thinking of going also much beyond this. So you remember the experience when you wake up when you are watching, let's say, Netflix in the middle of the night. Something goes wrong with your Netflix subscription and your favorite series just stops. Well, what do? Of course, you tweet to the customer service of Netflix and they fix the problem in 1 minute. And you just keep watching. Actually, usually in customer service, this doesn't really happen. Usually you end up pinging probably Netflix or whoever you are trying to contact many times. You don't get hold of the right operator. If you look at the customer experience kind of industry in this year, you have a tiny fraction which is the customer service industry, but much larger fraction of the industry is actually the customer disservice industry. And it's really interesting to see how you have these huge waiting times. Even if you are just tweeting a simple question, in this case to Xbox support, maybe after 6 hours you are told that, hey, you can sign in and fix the problem yourself. So I think you are getting the idea of what we want to solve at True AI. And I think the obvious solution to many of these problems is actually that we want to automate conversations in customer service. And it's fairly easy to do, actually. And this is what I'm going to tell you how to do it. The easy way to do it is you just get all the possible questions that the customer can ask, and you write the possible answers, and then you have just a table and you can look up everything. Very simple. Not quite. Actually, if you are starting to think about it a little bit more, maybe you want to have, you don't want to write, let's say, 1 billion different questions as answers. Maybe you actually want to use something like expressions to write this. And if you have played in the kind of domain of automatic dialogues, maybe you have come across something like AI/ML, which is the kind of language to write these kind of expressions. Maybe you say that hi name. If let's say hi and some kind of name comes in, then you respond with something like hi and then you repeat the person's name, for instance. Well, that's nice, but then if you say, let's say in the first comment, hi Peter, and then that person asks you how are you, then you actually want to remember that that person's name is Peter, and you can't really use just simple expressions. So what you start doing is you start constructing expression trees. You say that, okay, if I'm in this part of the tree, maybe this is what I want to do. And of course, constructing these expression trees can be also get a little bit tedious. There's still a lot of things that you want to construct. So maybe you want to build some kind of machine learning modules as well. Maybe you want to recognize, let's say, what are the named entities, or maybe you want to understand what is the intent. What does the person asking something actually want to achieve? And then you can maybe have another expression tree just figuring out how to answer to this. And if you start doing this, maybe maybe that starts to work a little bit. But what you start doing now is that you start probably constructing more trees and adding more modules and adding more trees, and all of a sudden you probably realize that you have spent 10 years constructing this. Or if you have a huge engineering team, maybe it's a little bit faster. For instance, the AI/ML, which is kind of the original way to construct these expressions, the latest file that I found had 40,000 expressions in it. So you can imagine that's maybe not the easiest way to do it. And of course, you can imagine maybe something changes in the organization, and maybe you need to change actually one of your answers. So you can imagine the amount of maintenance that is involved. So I think where I'm getting at with this is that you can use these kind of systems to build very simple kind of chatbot-like systems, but in general, rule-based systems and this kind of expression trees fail to really give a good dialogue experience. If you want to test something like this, there are tons of examples outside. For instance, IBM has their demo online. And it works quite nicely if you answer every single question correctly, but this is where you end up very quickly with it. So as kind of consumers or as people who talk to conversational machines, we don't really want systems that don't understand us and that you have to build for a long time before they start giving any reasonable answers. What we really want are systems that are learning, that are capable of looking how do humans interact and are able to interact in the same way. What we really need is, of course, true AI. And I'll tell you a small vision of what we are building at the moment. So what we are doing is that when Alice asks Virgin Media on Twitter, why is my internet stuck? What does the operator get? We are giving automatic suggestions to the operator. We are saying, hey, you could say this, this, or this. We are not actually giving automatic responses to many difficult questions. Why? Because the technology to do that is not exactly there yet. We are getting there, but answering every possible question automatically is not possible using today's technology. You can answer simple questions, but for most, it's actually more sensible to give automatic suggestions to operators, making their job much easier. And of course, we give a confidence measure. You know how good the suggestion is roughly. If it's, let's say, 99%, in that case, we may want to send it automatically. But we really keep the human operator always in control. You can click on this, and you will get the possible response here. You can still edit it. It's kind of an easier way to go towards something fully automated. And of course, if the questions are very easy, if someone is saying, why is my internet stuck? That's actually a question that repeats, maybe not in exactly this form, but in very similar form a lot of times. We can actually respond to the whole dialogue. We can go through it automatically. So this kind of a system is, of course, nice. It can save a lot of agent time. The customers who are trying to reach customer service are getting much faster responses. Who doesn't want that? And of course, you can get also better responses because the operators can really focus on the harder cases when they don't have to apologize to every customer in the same way. So, of course, a lot of companies, organizations could benefit from something like this. And it's kind of obvious this would be great, at least to most of the customers that we've spoken to. But why haven't you really seen anything like this before? The reason is that it's very new technology. If you think of artificial intelligence, it started maybe in the 50s, and kind of the traditional methods were used to, for instance, to solve something like chess in the 1990s. Machine learning came along maybe around in the 1990s, at least, as a more active research field. I think IBM Watson would be a nice example of how you can combine kind of traditional machine learning methods to build something actually very impressive, at least in a kind of small task. And of course, deep learning started fairly recently. So in 2006, 2007, you started having the first deep learning successes. AlphaGo is perhaps the most kind of famous recent one, where, for those of you who don't know Go, it's an ancient, I guess, Chinese or Asian game. And the Google Spot was able to outperform the best human on Earth in that. And recurrent neural networks is the technology that we are using. It's something that is a subfield of deep learning. And it's something that people haven't been able to use even when the deep learning revolution began. We started getting papers from recurrent neural networks in 2011 or so. And now people do know how the basic kind of models work, but it's a very active research idea, and that's what we are leveraging to build this tech. Just to give you a small idea of what kind of things we are doing, we are using very heavy deep learning research, and I just wanted to check what kind of level of knowledge in the audience we have. So just a kind of interesting question. Who knows actually what this image represents? If you know, can you raise your hand? I think we don't have many deep learning people in the audience in that case. So it's an LSTM. I think we had a couple hands up. So yeah, we are really taking a lot of research out of papers and putting this research into our product. We are experimenting with a lot of our own ideas also. But essentially, just to explain briefly how our tech works, we read some kind of query. So the query can be the latest question or the whole conversation. We have something called neural attention, which means that we can focus actually on the part in the query that is most important for answering. After that, our recurrent neural network can form something called a meaning representation. Someone calls this also a thought vector. So it forms kind of a computational representation of what is important in the conversation. It can include something like sentiment, intentions, key facts, but we don't really tell our system what to learn. It just figures out from a lot of data that these kind of things are what it should keep in its memory. And of course, after this, it can suggest responses. And the responses that we are suggesting, they are not template responses. They are kind of created in a human style. So they may even include casual language, emoticons, and so on. They are not templated, because that's what you don't really want as a customer. And our setup is, of course, completely machine learning based. So what we do is that we take millions of historical conversation logs. Because we are working with companies, I was doing before academic research, and actually there are no good data sets for this, to be honest. With companies, luckily, the largest customer service organizations have gathered data for years, and they do have millions of conversations, which is, of course, a very fruitful field for deep learning and machine learning research. Once we have these conversation logs, our algorithm learns how does a human typically respond, and it can start outputting these kind of responses. And of course, the ultimate customer, who's the kind of operator, they are getting these suggestions through our API to their existing CRM. So if they are using something like Intercom or Hootsuite, it just integrates there. It's very easy for them. They just give us their access, their data, and they start getting responses. This is just a kind of quick overview to the tech. But I also want to point out that we are doing this in customer service at the moment. But this kind of technology is not customer service specific. It's actually specific to conversations in general, or maybe even sequences, regardless of data format. But it can really be applied to any kind of conversations. Customer service is really just the starting point, because there's a lot of data, and it's good also for a startup to start there. But you can imagine, how often are you actually responding to a Google? For instance, me responding to David, thanks for the reminder and see you tomorrow. Maybe you have even seen something like this if you are using Google's inbox. They are using similar technology as us. And of course, over time, and I don't think this is fully possible today, but over time, this kind of technology can be used to automate any kind of conversation, even, let's say, medical conversation, if you want to converse on the phone with your doctor. So the possibilities of this kind of tech are very, very wide. We are still in early stages, of course, and something like this is not yet possible, but there's a lot of research on how to do this in the future. So I guess this more or less concludes my introduction to our company and the kind of technologies that we are using. I wanted to tell you briefly that we are looking still for a couple of employees. So if something like this might be interesting for you, we are looking for people who are interested in doing really cutting-edge AI research. For instance, my research has been already featured in MIT Tech Review. We have a team who has worked in the top labs of the world in deep learning. And of course, we offer an environment where you can really challenge yourself. So if you think this is interesting for you, feel free to send us an application. We are looking for deep learning research engineers and also a full stack developer and internships at the moment. So that concludes my talk. If you have any questions, I'd love to hear them.